Alright, welcome back. So now that we've looked at how we can calculate the sample space from two independent events, we can now look at working out the probability of these particular events, or an event within that, or an outcome. So let's look at the first one. A coin is flipped and a spinner numbered 1 to 5 is spun. What is the total number of outcomes? Well, first I'm going to fill out our sample space. Now, we've got coin and we've got die here, but just remember that this is a spinner. Alright, so we have heads and a 1, heads and a 2, heads and a 3, heads and a 4, and heads and a 5. And then the exact same thing for tails. So all this is saying is that we can either get a combination of either heads or tails and any one of the numbers 1 to 5. So the total number of outcomes is everything just within the space we just filled out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If you were wondering an easier way to work out maybe for a larger number of outcomes, you just multiply the number of outcomes from each independent event. So there are 5 outcomes for the spinner and 2 outcomes for the coin. 5 times 2 is 10, so the total outcomes is going to be 10. Looking at B, find the probability of getting heads and a 3. Now remember that we have to work out probability of heads and 3. It's the number of favorable outcomes, the number of outcomes that are this, divided by the total number of outcomes. Now, total number of outcomes is 10. So we know that all we need to work out is how many of our outcomes involve getting a head and a 3. And the only one that has both of these occurring is going to be this one here. So there's only really 1 out of 10 times when we ran this experiment would we expect to get a head and a 3. Right, let's get on to the next one. C, find the probability of spinning an odd number with tails. So where are our odd numbers? We've got 1, 3, and 5. So probability odd plus tails is going to be something out of our 10 possible outcomes. Now what's it going to be? Well, we have a tails and a 1, a tails and a 3, and a tails and a 5. So there's 3 possible outcomes where we have an odd number combined with a tails. Everything else does not mix, does not actually work out. So a tails and a 4 doesn't, a tails and a 2 doesn't, and everything here doesn't involve a tails at all. So there's only those 3 outcomes, and these are both our probabilities. So you can see why it's very helpful to create this table of the sample space. Alright, let's have a quick look at another one. Alright, in this one we're using the same spinner, but we're spinning it twice. It has 4 colors on it: red, blue, green, and yellow. So each independent event is actually spinning it once and then spinning it again. And we're just going to do the exact same thing. All we're going to change is that we're not going to have any numbers. So we're just going to have letters. So this outcome here is going to be red and red, red then blue, red then green, red then yellow, and so on. Sorry, this is green and then red, and this is green and then blue, and green and green, and green and yellow, and then yellow and red, yellow and blue, yellow and green, and yellow and yellow. Okay. So now that we've done that, that's our entire sample space showing all the possible outcomes that can occur. If you look up the top here, we have 4 possible outcomes. in either independent event, which means ultimately the number of total outcomes we'll have is going to be 16. 1 column of 4, 2 columns of 4, 3, and then 4 columns of 4. So total outcomes is equal to 16. Alright, so for B, it's going to ask us, what's the probability of getting blue and then blue? Well, there's only one outcome where we have blue and blue out of the entire 16. So the probability of blue is going to be equal to a number of favorable outcomes, which is 1, divided by our total number of outcomes, which is 16. Alright. Probability of getting 2 different colors. So probability of different colors. Alright, we know our total outcomes are 16. We just need to work out what our favorable outcomes here are. So if we look at where we get our same colors, we're getting 1 here, 1 here, 1 here, and 1 here. So there are 4 outcomes where we get the exact same colors for both independent events. But everything else is going to be different. That means that we've got the first 3 here, or you can just say we take away these 4 from the total number of 16. So 4 away from 16 is just going to be 12. So 12 out of 16. And you can simplify this down if you would like to, but at the moment, just think about it. Out of the 16 possible outcomes and you have 12 of them. If you divided both the top and the bottom by 4, then you would get 3/4. So you have a 3/4 chance of getting a different pairing of colors, and only a 1 in 4 chance of getting the same colors back to back. But again, it's important just to remember that what we're trying to do here is just work out the probability. If you haven't really gotten used to simplifying fractions, that's okay. You can leave it at this point if you would like to. Alright, that's it for this video. Hopefully it was helpful, and I will see you in the next one.